All right, here's a few questions where you are solving equations. And I think for the most part, things were done well in questions. I'll just clean up a couple. So this first one, x equals minus b, so b is a -4. So careful with that, eh? I like to put brackets wherever there's a variable, and it helps me so I don't make mistakes on negative signs. So b is a -4, so here's another -4. A is 1 and C is 13. Yeah, okay. So, and A is a 1. So this will be a positive 4 plus or minus square root of -4 squared is 16. 4 times 13 is 52. So it'll be minus 52 over 2. So 4 plus or minus. Now 16 minus 52, what's that? That's 32. Oh, and it's a -32 over 2. Oh, but this one says solve by completing the square. Okay, well, we could finish off doing this, and this is worthwhile to do, but so 4 plus or minus. Now there's a negative in there, so to deal with a negative, that's complex numbers, and so you can rewrite this as the square root of 32 times the square root of -1 over 2. So 4 plus or minus, now 32 is the same as 16 times 2 times the square root of -1 all over 2. And so this would be 4 plus or minus, square root of 16 is 4, root 2 is there, and whenever there's an I, you can, or wherever there's a square root of -1, you can replace that with an I over 2. And then 2 divides into both of those, so it'll be 2 plus or minus 2 root 2I. Okay, hopefully that helps you with number 5. Now number 6, I think that you are good right to there. So minus 64 plus or minus square root of 192 over 32. And 192, you could separate like you did there, is 12 times 16, but I think 64 goes into a 2. So I could write minus 64 plus or minus square root of 64 times the square root of 3 all over 32. And then square root of 64 is 8, root 3 over 32. And then similar to what I did here, but 32 won't go into 8 evenly. So what you can do is just separate those into 2 fractions, because that's 32 is a common denominator. So negative 64 over 32 plus or minus 8 root 3 over 32. So this first one, 32 goes into 64 twice. That'd be -2 plus or minus, and then 8 goes in itself once and into 32 4. So it'd be root 3 over 4. All right, hopefully that helps you with those square root questions. Now here's a couple other ones. So this first one, they give you a quadratic function right there. And I'll just sort of give you an idea of how to go about it. So here's my function, 0.12x squared minus 0.543x plus 35.725. And this stands for how many multi-generational households there are. So they say, in what year were there 40 of those, or 40 million? And we're just going to use the 40. So I can plug that 40 in wherever I see an h of x. So it'll be 40 is equal to 0.012x squared minus this. And now I want to solve for x. Now to do that, since it's a quadratic, I need to make it equal to 0. So I'll subtract 40 on this side, subtract 40 on this side. So 0.012x squared minus 0.543x plus, well, that'll be a minus 4.275, I think. And at this point, there's lots of troubles. Or I guess not lots of troubles. I'm trying to factor it, but it's pretty hard to deal with those numbers. And so what I would do is just go and resort to using this formula. And again, when you use the formula, you got to be careful of the negative signs. So I would just rewrite the whole thing without putting letters in, just rewriting instead of a letter, putting in brackets, and then plug the numbers in. So B is a negative 0.543, B negative 0.543, and when you put it in your calculator, putting brackets around is a good idea too. A is 0.012, C is negative 4.275, over A is 0.012. And then you can put that in your calculator, and for one go through, put a plus in, and for the next go through, put a minus. So you'll get two answers for that. All right, last question has to do with a box. And the box is a tough question. This is Pythagoras, and what you did there, that would give you the distance from here to there. But but I want to know what do they say? The lengths of the sides of the squares. The area of the resulting base is that. The length of the sides of the squares. Oh, that must be these guys here. So that distance there. So I don't know what that is. Let me just try one a little bit bigger. So I've got this thing, and then we cut out these corners, and then we fold this stuff up, right? We fold this up, and it gives you a structure like that. So this distance I know from there to there is 40, but then I don't know what this distance is, or that distance. So we're going to call both those distances x. So the distance from here to there, or really more what I want, from here to here, is going to be the whole 40, take away those two x's. So that, well, I shouldn't have drawn that. It's from here to here. So let me erase that. So the distance from there to there is going to be the whole 40 minus those two x's. Now similarly, if you want to know the distance from there to there, it'll be the whole distance, which is 70, minus those two x's again. So from there to there, 70 minus 2x. And that's the distance that I'm wanting inside that box. Okay, so the area then of a rectangle is length times width. They say the area is 2176. The length is 70 minus 2x, and the width is 40 minus 2x. So now I'll FOIL this stuff on the right. 70 times 40, 2800, minus 140x, minus 80x, plus 4x squared is equal to 2176. And now it's an x squared, so I need to make it equal to 0. So subtract 2176 on each side of the equal sign. So I get 0 is equal to, this will be, what, 624, I think, hoping. These together would be minus 220x plus 4x squared. Let's rewrite it so it's in the proper descending order. And then if there's a 4 out front there and it's an equation, it'd be nice maybe to divide that out. So let's divide everything by 4. 0 divided 4 is 0. This divided 4 would be x squared. This divided by 4 I think is 55. And this divided by 4, I don't know, 1, 5, that right? 1, 5, and 6. Yeah, good. All right, so now I'll want to try and factor that. So I think that's right. So I will factor. I'm just looking at it and I'm thinking I might have made a mistake somewhere. I think it's pretty good. Okay, so I paused so I could figure that out. I think it's 3 times 52. So x squared minus 52 minus another 3 gives me that. And 3 times 52 is 156. So therefore, if it's equal to 0, either x minus 3 is 0 or x minus 52 is 0. So x is 3 or x is 52. But when you look at the diagram, if this whole distance is 70, and you have to take off two x's, an x there and an x there, both x's, if they were 52, that wouldn't make sense because you only have 70 and you're taking off two 52s, it won't work. But if you put a 3 in there, an x value of 3 makes some sense. So the value or the length of the side of those little squares are going to be 3. Now we don't know what the length and the width are, but I guess if it was 40 and I have to subtract two of those 3's, 2 times 3 is 6, so that'd be 34 would be the inner part of that tray that they made, and then 70 minus two of those 3's, or 64, would be the other side. All right, hopefully that helps you with those few questions.